So I know wearing this t-shirt looks a little strange, but it's Superhero Day here at the school where I teach on the day that I'm recording this. So what I'm going to do in this video is explain some of the details of how to set up your post lab for the Magnets and Metal Ions lab. Okay, so you should be working on the orbital notation for manganese. And manganese is located right here on the periodic table. It's not magnesium, it's manganese. Okay? And so we have both the first, well, all three, 1, 2, 3 primary levels full. And we're going to fill up the S sublevel in 4, drop back to 3D, and put in 1, 2, 3, 4, 5 electrons. Okay? So we're going to fill up everything. Remember, 1 electron in each box. Come back and pair them up. On each box. Come back and pair them up. 4S is full. And then manganese has 1, 2, 3, 4, 5 electrons in 3D. 1, 2, 3, 4, 5 electrons in 3D. Okay? Now, on your handout here, you have 2 different ways of work. You got 2 different sides. They both look exactly the same, except the instructions here at the top. Okay? So let's start with one of these. And it really doesn't matter which one you start with. Okay? You can do one or the other. So then, here's the primary energy level up here. And that's all we have right here. Okay? So I'll put this in here. I'm going to notice I'm doing this in pencil. There's a reason for that. So if I have a 2+ charge, I need to erase, you're right, erase some electrons. Now, when I built the orbital notation, I put the first 2 electrons in 4s, and then the next 5 electrons in 3d. So in this first possibility, I'm going to erase 2 electrons from 3d. Okay? Got it? And that's how I get that 2+ charge. So how many unpaired electrons now do I have?
2,
1, 2, 3 unpaired electrons. Okay? Now I'm going to flip over to the other side. And I'll fill out the same stuff.
Can I get a new sheet?
Okay? So which one of these is the highest primary energy level? 4s is the highest primary energy level. So let's remove the 2 electrons from 4s for this one. Yeah, this is number 2 side is what I'm working on. It doesn't matter which side you're working on. As long as you do it consistently one way on one side and consistently the other way on the other side, that's what you do. Okay? So here I am removing electrons from highest level. You might want to write a note to yourself so you remember what you're doing.
Wait, what about the other side?
Okay? On the other side, I'll remove them. Removed electrons from, let's see, in reverse order. How about that? I'll put it that way, in reverse order. In reverse order from the way that I put it in. And that way you keep up what you're doing. Now that's all I'm saying. Just keep it consistent. You with me? No. Be consistent. Same thing on this side. That's what you do on this. And then same thing on this side.
Okay, can I get a new sheet of paper? Because
There's more sheets up here. Come get one if you need it. So if I'm removing them off in reverse order up here, I put them in 1, 2, and then 1, 2, 3, 4, 5. So that took them out in reverse order. That's all it did. And I got 3 unpaired electrons, 1, 2, 3, that don't have a pair. And over here on this side, I took them out from the highest level, here at 4s. So I have how many unpaired electrons? 5. Okay? Now what we're going to be doing, even though this column over here, I need to change this. This is no longer, you have in your, when you did the lab, you had a mass change you recorded. So when you measured manganese, the manganese ion compound that I gave you, you had a change in mass, right? All right, so your change in mass, what you're going to put there.
wait,
And you can put the same change in mass there and there because you're working with manganese both times.
the change in mass is the one that
You measured it in the lab. You held it over the balance. You held it over magnets, and you got a change in mass. Now, I hope you were very careful about reading what was on that screen, okay? Because everything that's on that screen on your digital balance is important. All right, so I'll record your change in mass. You got that?
Yep.
Now, you're going to do that for all these ions, okay? If this is the side of the page that I'm going to take the electrons out in reverse order, that's what I'm going to do for all these ions. So iron's going to be a little bit different, cobalt's going to be a little different, and so forth. Okay? If I want to take it out on this side, from the highest level, I'm going to start by taking electrons from 4s first every time. And if I need to take more electrons then I'll go back down here to 3d and take whatever electrons need to be taken out. Okay? In reverse order. Got it?
Yep.
Now remember, if you put them in like this, one in each box, and come back and pair them up, then if you need to take an electron from down here, you take out the second one here in the order. You take them out in the order you put them in. Does that make sense? Okay. Now, having done all that, then you have to calculate the change in force. Now, when you're doing practice work or trying to figure things out in science, you got to keep good notes. What if you started doing this side and forgot what you were doing? Say you were doing working on it, after school you had 15 minutes after school, you worked on some of it. You go home, could you remember what you did if you didn't write it down? Make sure you write it down, okay? Make sure you keep good notes on what you're doing so you know where you're going to pick up from later on. All right, that's what we're doing here. Now, so here we're going to remove the electrons from the highest energy level. I'm sorry. We removed them from the highest energy level on the flip side. We're now going to remove them in the reverse order of the way we put them in. What were the last two electrons we put in? What were the last two electrons we put in? The last two in 3D. Guys, if you're just waiting for me to give you an answer, you're not helping yourself very much. You need to be thinking this through and imagining in your own mind what's going to happen. How many unpaired electrons do we have now? 3. Okay? Now, the mass change doesn't change. Okay? The mass change you measure is going to be the same on both sides. Now, your group may have a different mass change. Don't write down Mason's mass change. Okay? That's their groups, not yours. All right? Now, then find in the email that I sent you guys, which gave you the written procedures. I sent you 2 emails last week. Let's see. I sent you one. I forget, one on one day, one on another, but the second one repeated the first one and also added some stuff to it. But it gave you written procedures there. And if you find that written procedures, it looks like this. Let me make this smaller so you can see what's going on. Okay, this is what I sent you as an attachment to an email. Okay? And it explains the procedures you're going to be using in the lab. And you're supposed to read this and also watch the video that I prepared for you. But if you scan back here to the bottom, of the second page anyway, you'll see the math you're going to need for figuring out the mass change, the change in force from your mass change, okay? So if you look right here, that's what force, or how force is measured. Newtons is a measurement of force, and it is kilograms times meters per second squared. But you don't have that yet. What you have to do is figure that out. Okay, so what I'm going to do is scroll down just a little bit here and give you this equation right here, which I prepared for you to help you out. And so you should remember 9.8 meters per second squared. Where have you heard that before? Nobody's heard 9.8 meters per second squared? Really? 9.8 meters per second squared. No, we didn't use it in this class. What? No, that's what you should have learned in 9th grade in physical science for the acceleration due to gravity. I understand, but you should have learned it.
Yeah, I remember.
Okay? You know, when you were studying all those equations and things that Newton came up with? Newton, really? Newton. How do we measure force? Newtons. Okay. Anyway, 9.8 meters per second squared is acceleration due to gravity. You apply gravity on Earth anyway. You apply gravity, the acceleration, to an object and you get force. Okay, so what we have is a change in mass in this lab and you have a mass change you're going to put in right here at the top. Okay, so for this group anyway, they got a negative 0.15 grams. Now, why would mass be negative? Mason, I know you know the answer to this already because you asked me about it. The magnet was being pulled up toward the sample of that chemical. Okay, and so you relieve some of the mass that was being pushed down on the balance by gravity. Okay, and so really, it's not really a negative mass; it's just the effect on the balance. Well, according to what we have here in this equation, okay, we're going to do change in mass in grams on the top, and we'll go of a fraction, put over 1. Huh? That's what it is. Okay, because why? Why is it negative 9.8? Gravity due to something. Okay. Maybe you need to go back and watch this video. Okay? Just saying.
I have a quick question.
Yes.
Okay, so change in grams is going to be the average thing?
Yep.
Okay.
Change in grams is going to be your average. Okay? Now, we need to have our answer, listen carefully, in kilograms per meter, or kilograms times meters per second squared. Okay? But I don't have it right now in kilograms. How do I change grams into kilograms? Well, we don't move decimals around. What are we doing here? Oh, we do multiply it by do we multiply by 1,000? Really? Really? So what's the process we use in here? What do we have to do to convert in here? Well, before you can do it in here, you must have an equality statement. How many grams in a kilogram? You should know this from Unit 1, guys. There are 1,000 base units in any kilo unit. You got to know that, okay? So therefore, there are 1,000 grams in a kilogram. Okay, this is the basis behind dimensional analysis. Dimensional analysis is the basis behind stoichiometry. We got a whole unit on stoichiometry. So you need to get this committed to memory if you don't have it from Unit 1, because we practice this a lot in Unit 1. Okay, now how do I build a conversion unit based on an equality statement? How do I build a conversion unit based on an equality statement? Yeah, put whatever you can cross out. Where am I going to put it, top or bottom, to cross out something? Kilograms going to go on top. Grams go on bottom, because that allows us to cancel out grams. And when we're done, we're going to have kilograms times meters per second squared. Now that will be the force. That will be the force we're measuring here, or calculating here, just on this one measurement, okay, or this average measurement. You have how many different chemicals you're testing? 6 of them. So you're going to have to do these calculations 6 times, okay, to be able to put together your graph. Now, well, but I guess what I did? I was nice to you by sending you a spreadsheet in your email, and all you got to do is plug it in one time if you just use the spreadsheet to do the work. But you must, listen to me carefully, you must have a sample equation, excuse me, for one change of mass that your group got in your lab logbook. You must have a sample equation from one of the average masses your group got in your lab logbook. Got it? Yeah, this is basically, you got yours right here. Okay? All right. Now, once you got that, you're going to have 6 different changes in force, okay? 6 different changes in force. So, if you go to your Google Chemistry folder, you're going to find a document in there named just like you see here on the screen. Okay? Magnets and Unpaired Electrons report. Now, you're going to have to build a table. So one of the videos that you're required to watch that I sent to you, links for which I sent you in an email, but you can find it on my YouTube channel. Just go to the YouTube channel and find tables and the playlist for tables and graphs. You can find these videos. Explains exactly what you need for a formal table and graph. Okay? And in this table, you're going to need to be able to put in the data that you have either measured in the lab or calculated as a result of the lab. So, now, if you notice what I've done here for you, I've kind of helped you out here a bit. I can find there's a mouse. Huh? All right, so table 1, you have to number your tables in this fashion. Capital word table, capital letter table, 1, period. If there's a second table, it's going to be table 2, period. Then you got a table label here. You have to replace what I've written. If you keep what I wrote for you, points off. And the video link right here, you can go watch the video again, or another video like it anyway. All right, column labels. Make sure you label columns, and if there are measurements or calculated numbers in that column, you list in parentheses what the units of measurement are. All right, in column number 1, you might want to put the name of the chemicals. So column label might just be the name of the ion, okay, or the symbolic symbol for the ion or something, okay. Column number 2, well, you're going to need to have your mass listed somewhere. That'd be a perfectly good place to put column 2. Mass change for the testing for such, these ions. And column number 3 might be the force that you calculated. So you've done 6 calculations. You might put those in this column. Okay, and you've got 2 different number of unpaired electrons. Okay, 2 sets of unpaired electrons. You might put those in that column and that column. Does that make sense? Then you got all your data in one table. Make sense? Now, when you're getting ready to do the graph, and that's on the next page in your Google form, you're going to need to start with Logger Pro. Okay? With Logger Pro, you need to put in column X here. Let's see, what's the independent variable for this? Well, you didn't actually change the number of unpaired electrons, but you were comparing ions with different numbers of unpaired electrons, right? So that is your independent variable. You, by virtue of choosing to use different salts, different metal ions, you chose to have different pairs or different sets of unpaired electrons. So you can do 2 different graphs, and this column is going to change. Okay, the first time you're going to put one of these sets of data for unpaired electrons here. So if you double click there, it'll allow you to change the axis. Okay, remember you got to label the axes properly. Okay, so you're going to label the top of the column and the axes in the correct form. Okay, put in your number of unpaired electrons there. In Y, change the titles on it as well. Put in the force change for each of the different forces you got once you calculated those. The thing you changed was the number of unpaired electrons. Okay, you need to put a title in here. If you click here near the top edge of this graph a couple times, it'll give you a place to change the title. What format should your title be in? Right, and remember, you don't say the effect of and say the words independent variable. You're going to describe independent variable in that sentence. Okay, it's the effect of the independent variable on the dependent variable, and tell me what the independent variable is in that title, what the dependent variable is. Okay, and that's how you're going to build a graph. Okay, now once you're done, you need to have a best fit line. Remember, the quick shortcut way to get a best fit line is this icon right here. Click that icon, it'll automatically put in a best fit line for you. Okay? All right, once you've got your graph built, click on the white area around the graph, and if you notice, once you click the graph, you see these little boxes in the corners? See these little boxes in the corners here? Those are telling you you've highlighted the graph. Now you're ready to copy. A lot of ways to copy. Okay, you can go to Edit, Copy. You can right-click and say Copy. Okay, you can hit Control-C on your keyboard. I'm going to do it this way since I've already popped it up this way. I right-clicked and I'm going to click Copy, so I've copied the graph. Now I'm going to go back over to my Google document. Okay, and what I've done is I've told you where to put the graph. It says, guys, I know you guys can read. Please read. Okay, it says delete this sentence and replace it with a captured image of your graph. Okay, please don't leave that sentence in there. All you got to do is read. It's a simple sentence. There aren't a lot of multi-syllable words here. I know I'm being sarcastic, but you can read. I know you can do this. Okay, and we're just going to replace it. So I've copied it. Now I'm going to paste the graph in there. Okay, and There's the graph. Of course, I don't have anything on it, but that's the graph I just copied and pasted. Okay? Now, read what's under here. I've helped you out by listing that figure label for you, but you have to finish it out. Figure labels are always labeled figure 1, or in this case, you're going to have 2 graphs. What's your second graph going to be called? Huh? Figure 2. Right. Come on, guys. Only one person speaking up, not 2 people. Huh? The second graph will be the data you got from the second way of removing electrons. Okay? You got one way of removing electrons and a second way of removing electrons. That's going to change your x-axis. Okay? You do all the same stuff with this graph. Build your figure label. Okay? Figure labels have to have 3 things in them. What's important, what's in the graph, why it's important, and what the analysis tells you. Okay? What does it say about how the independent variable is affecting the dependent variable? That's the analysis I want you to write in your figure label. When you have built your 2 different graphs, one graph will have an x-axis, a horizontal axis, an independent variable with one set of data for the number of unpaired electrons, and then you'll flip over and you'll build a second graph, flip over the worksheet, and build a second graph from the same mass measurements from which you got your force measurements, your force calculations. But you'll change the x-axis and you'll have a different numbers for the number of unpaired electrons. And so you'll have a second graph. And you've got to compare those 2. Once you've built the graphs, once you've written your figure labels for both of those, then you're going to go to the bottom here on this report and write a conclusion. Now in nature, we're always looking for patterns. That's a big part of what scientists do, looking for patterns in nature. So in the conclusion, you're going to look at both graphs and figure out which set of data, which of those little points on the graph best fits a line. One of them will be all over the place, and the other one will be kind of all over the place, but a little bit closer to a line. One of the 2 sets of data will be closer to that pattern of a line than the other one will. Now, they're going to be all over the place because that's the way nature works. It's never pretty like we'd like it to be, or it's rarely pretty like we would like it to be. It's going to be kind of all over the place. So the lines you're going to have are going to be there because of a best fit line from the graph program, but the data is going to not be right on that line. One graph will have a set of data that's closer to the line, and another will have a set of data that's way off the line or more off the line. And the one that's closest to the pattern of the line is the one that you will conclude is the most likely way that electrons are removed from the orbital notation or from the electron structure of an atom. And so that's going to be your conclusion. If removing electrons from the highest primary energy level makes the most sense based on the pattern, that's what you'll say. If removing electrons in reverse order to the way you put them in to the orbital notation makes the most sense, that's what you will say. And so you're going to write a conclusion based on that because one fits a pattern better than the other. And you're going to write it in here in this conclusion section of the report in your Google folder, so it's a Google document you're writing in. And make sure that you put in your name, the correct date for the lab, the description of what this is, that's the name of the lab, a descriptive title for the lab, what we did in the lab, what class period you're in. Make sure you fill all that in as long as all these other sections we're talking about.